Hey guys, welcome to the unit circle notes. So the first thing we're going to talk about is what is a unit circle. So a unit circle is basically a circle that has a radius of 1. And generally it's centered at the origin 0, 0. So what you should have, or you should be able to see, is that you have a blank unit circle paper. And what we're going to do is we're going to fill out. And I technically have two of these. This is going to be my working unit circle. I'm going to draw all over this and mess it up just to try and show you what things are. And then my next one is going to be my nice unit circle, where I fill in the values, and this is going to be my reference. So you're going to fill in the nice one, and maybe hopefully understand the working one. All right, so the first thing I'm going to look at is I'm going to fill out the degrees. So some of the ones that we should already kind of have an idea. I'm actually going to go over to my nice one and fill this out. This is 0 degrees if I don't go anywhere. If I go all the way around, it is 360 degrees. Halfway, so if I go halfway around, this will be 180. Halfway between 0 and 180 is straight up. This is 90 degrees, because this should make a 90-degree angle. So plus 90, so this bottom one straight down should be 270 degrees. That's not a 2. And then again, back around is 360. All right, so then now let's look at our ones in between. So I'm on my working one. All right. So now let's think about it here. I'm going to just look at this first quadrant. So this makes a 90-degree angle. And what I've done here is that I've broken each one of these sections. I've broken, trying to get this 90-degree section into 3 pieces. So if each one of these sections, if I add up, are equal, and I add them all up, that means each one of these measures should be 30 degrees. So that this first section will be 30 degrees. And then if I make 2 of them, this section will be 60 degrees. And then if I have all 3, I'll have 90. So basically, each one of these pieces here is a 30-degree measure. So to get the next one, I can simply just add 30 degrees to the previous one. I'm going to go over to my nice one, and I'm going to fill out these. So if I add 30 degrees, 60 degrees, add 30 from 90, so I get 120, 150, 210, 240, 300, and 330 degrees. So hopefully we're okay with that. I also determined on my nice one, I'm going to write everything in red. On my working one, all the stuff will be in green. So let me erase this. All right, so now we figured out the breaking it to third sections, but notice that on our other one, we skipped the one in between. So here, this one in between is breaking our 90-degree into 2 equal sections. So this would have to be 45 degrees, and this would have to be 45 degrees. So to get these middle sections, I'm going from 0 plus 45, so this would be 45 degrees, plus another 40 to get 90. And what I'm going to do to get every in-between one is add 45 degrees. So let's do that. So this will be 45 degrees, plus 45 is 90, plus 45 is 135, plus 45 should give us 180. Scroll down. So 180 plus 45 will give us 225. 225 plus 45 is 270. 270 plus 45 gives us 315. Plus 45 gives us back to 360. So there's different ways that we can memorize those, but you should now have all of the degree portions filled out on our nice one. All right, so now what we're going to do is we're going to look at the radian measures around the side. So let me erase this. All right, so now when we look at radians, hopefully we remember if we don't go anywhere, this should be 0 radians. And a complete way around, all the way around the circle, will be 2 pi. So now if the whole circle is 2 pi, that means just half the circle would be 1 pi. So now if the top half is 1 pi, if I cut that in half, I should have half a pi, which is pi over 2. So that means each one of these sections is half a pi. So I have 4 quarters, so this is 1 half, 2 halves, 3 halves. So straight down will be 3 halves of a pi, or 3 pi over 2. So 1 half, 2 halves, 3 halves, and 4 halves, which is 2 pi. All right, so we can fill out the nice 4 quadrants on our nice circle. So 0, 2 pi, pi over 2, pi, and 3 pi over 2. So yes, technically what you could do is you could take all of these radians and multiply them by pi over 180 and reduce to get the radian amount. We're going to look at it as kind of how we just did the degrees by breaking it up into pieces. So we're going to do a little bit backwards. I'm going to break this into this slice first. All right, so if a quarter of the circle is half a pi, and I cut that in half, so if I cut a half in half, hopefully you should see it's 1/4 of a pi, so pi over 4. So now each one of these slices is pi over 4. So this one technically is 1 pi over 4. This would be 2 pi over 4s, which again will reduce to pi over 2. Add some more of these. So this one would be 3 pi over 4, which doesn't reduce, so that would be this value. Here I would have 4 pi over 4s, which reduces to pi. I already have that one written down. This one would be 5 pi over 4s, which doesn't reduce. This would be 6 pi over 4s, which can reduce down to 3 over 2. This would be 7 pi over 4s, which doesn't reduce. And this would be 8 pi over 4s, which will reduce down to 2 pi. So there we have all of the middle ones are some type of iteration of pi over 4s. So I just like to count them. 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to go to the next slide. Goodness gracious. And quickly fill these out. This is pi over 4. 3 pi over 4. 5 pi over 4. And 7 pi over 4. All right. So I'm going to erase this and we're going to do the next one. All right. So now we're going to look at this slice. So the measure of this slice in radian. Now it's harder, before we were able to take half of this and then kind of divide it up. But sometimes it's harder to visualize what's a third of a half? So what I'm going to do is I'm going to extend this all the way to a whole. So one whole, and then break it up. So notice all of these should add up to 1 pi. And let's see how many sections we have. So we have 1, 2, 3, 4, 5, 6. So I have 6 sections that add up to a whole, which means that this first section, or each section, should be pi over 6. So this is 1 pi over 6, which doesn't reduce. This next one would be 2 pi over 6's, which will reduce to pi over 3. And then I'll have 3 pi over 6's, which will reduce down by 3 to pi over 2. And then I'll have 4 pi over 6's, which can reduce down to 2 pi over 3. And then I'll have 5 pi over 6's, which doesn't reduce down. And then I'll have 6 pi over 6's, which will reduce down to 1 pi. So let's look at the bottom quadrant. Go ahead and make these slices as well. All right, and I just keep on adding pi over 6's. So this is 7 pi over 6, which doesn't reduce down. Add another one, so I get 8 pi over 6, which will reduce down to 4 pi over 3. Then I'll have 9 pi over 6's, which will reduce down to my already 3 pi over 2. 10 pi over 6, when I reduce by 2, I get 5 pi over 3. 11 pi over 6's, which doesn't reduce down. And then 12 pi over 6's, which will reduce down to 2 pi. So things to notice, the pi over 6's are the ones that are closest to your x-axis. They won't reduce. The ones that are closer to your y-axis are pi over 3's, and they reduce down. So let's go ahead and fill out the other one. So this will be pi over 6, pi over 3, 2 pi over 3, 5 pi over 6, 7 pi over 6, 4 pi over 3, 5 pi over 3, and 11 pi over 6. So we have the whole inside filled out, all of the degrees. So now you're probably looking and wondering, what are all those coordinate points on the outside? Well, remember, we said that it is on the unit circle has a radius of 1 and a center of 0, 0. Let me erase this on our working one. All right, so unit circle, that means that this center right here is the origin 0, 0. And a unit circle has a radius of 1. So if I go out this way, this point should be the point 1, 0. 1 on my x-axis and 0 on my y. This point right here should be the point 0, 1, if I was to plot this on a coordinate point. This point would be the point -1, 0. And this one down here would be the point 0, -1. So now, those are the 4 nice, pretty easy ones. So now our goal is to figure out, well, what is the other coordinate points? So we're trying to find, if this was a 30-degree angle measure, and this is 1, what is the x length that I have to go over and the y length that I have to go up? So first what we're going to do, fill out our nice, pretty points on here. And then we're going to kind of work through how to find the other ones. So I'm going to go back to my first original page with all those little unit circles. And what I'm going to do here is I'm going to put this unit circle on a coordinate plane. And the first angle measure, let's do the 30-degree one first. So this is 30 degrees. And our goal is to find this coordinate point here. So what I'm going to do is I'm going to drop this down and make a right angle, which means this would be 60 degrees here. So if you remember from geometry, you're at 30, 60, 90 triangles. This should be pretty easy. I'm going to assume that you don't remember any of that. So all we know so far is that this length right here is 1. Well, what I'm going to do is I'm kind of going to make another triangle, and I'm going to reflect it along the x-axis. Where this also has a 30-degree measure, and this is 1. So that this angle down here would be 60. Well, now this triangle that I have formed is a 60 degree by 60 degree by 60 degree. It is an equilateral triangle, which means that if all of the angles are 60 degrees, all of the side lengths have to be equal too. So if this is 1 and this is 1, that means that this distance here is 1. Well, remember, we only really cared about half of it. So if the whole thing is 1, then that means half of it is a half. So the height, or the y value of this triangle, is 1/2. And now I'm going to use the Pythagorean's theorem to find the x value. So here I have x squared plus 1/2 squared equals 1 squared. So x squared plus 1/4 equals 1. So x squared, if I subtract 1/4 from each side, this will equal 3/4. Square root each side. So x equals the square root of 3 over 2. So this coordinate point right here is the square root of 3 over 2. Now hopefully we realize that we didn't do all of that work just to get 1 point. This is actually going to give us 4 points. So this coordinate down here, if we did the same thing, the only difference here is that this has a negative y. So this point down here, the x value of square root of 3 over 2 should be there, but now that's a y value of negative 1/2. And the same thing, if I had built my triangle in quadrant 2, which this is the 150, because this would be 30. This coordinate has a negative x value and a positive y. So this would be negative square root of 3 over 2, 1/2. And if I had built my triangle in quadrant 4, down over here at 210 degrees, both the x and the y values here are negative. So this is negative 3 over 2, negative 1/2. So I'm going to put these on the unit circle, these coordinate points on my nice unit circle. So at 30 degrees, this should be the square root of 3 over 2, comma 1/2. At 150, this would be a negative square root of 3 over 2, positive 1/2. At 210, it'd be a negative square root of 3 over 2, negative 1/2. And at 330, it'd be the positive square root of 3 over 2 and negative 1/2. And I'm actually going to stop this video here today, and we will do the second half. I don't want to make the video too long, and it's at about 20 minutes, and that's a little bit longer than I wanted it to be. So we're going to finish creating this unit circle and do a couple more things with it in the next set of notes. All right.